G'day, in this video we're going to learn about differentiation. This is an introduction to it, so we're pretty much going to learn exactly what it is, and then we'll do a few examples of it. So, first off, I'd like to draw a function. So, it doesn't matter what function it is. I have the particular style of function I like to draw for this kind of explanation, but actually what I'm going to say applies to any function. Okay, so well, I better give it a name, I guess. This is the function y of x. You put x in. This is what comes out. So I don't know. Let's say that this point here. Don't get confused by the notation. This red x is a label. So I put the red x in. Then the thing that comes out is y of red x. Okay, so that's what comes out. That's what this graph means. If you're not sure what this graph means, go back and have a look at the functions basics section. Explains it all there. Okay, and now what we're going to do, we're going to add h to x. So this is going to be x plus h. And then so this thing here on the y-axis, when I draw should be a straight line. Sorry if it's a little wonky. I know this one's a little wonky. Shouldn't be wonky. So the thing that comes out of the function on this axis is y of x plus h. Okay, so I've got 2 points on my function. I got the point x and y of x, and I've got the point x plus h and y of x plus h. Now I'm going to draw a straight line through those 2 points. I'm going to draw a straight line through those 2 points. So here I go. Should be a straight line. Ah, that's terrible. Let me have another go. Need to be on more of an angle. Didn't get the gradient right. Okay, that's better than I thought it would be actually. Okay, so that's a straight line that goes through those 2 points. And now I'm going to work out the gradient of this straight line. Well, it's actually nice and easy to work out the gradient because I have all the information I need. Remember, the gradient should be the rise over the run. This thing here is the rise. This thing here is the run. So rise over the run, the height divided by the base, right, of that right angle triangle there. Okay, so what is the rise? Well, the rise is going to be, well, this distance here. That's the rise. So it's going to be y of x plus h minus y of x. Y of x plus h minus y of x. So that's the rise. And the run is this distance here. The run is this distance here. Well, that distance there is clearly x plus h minus x. X plus h minus x. Well, x plus h minus x is simply h, because, you know, you've got x minus x there. So the run is just h. And therefore, the gradient of this line, the gradient is actually equal to, I've completely run out of space, so unfortunately we're going to have to go onto a new board. Gradient, I don't want to use that color, I'll use black. Gradient, now my pen's not working. Gradient is equal to y of x. Oh, there's the other g now that I drew. Gradient is equal to y of x plus h minus y of x divided by h. Please ignore that green g. So the gradient is equal to y of x plus h minus y of x divided by h. And that's the gradient of this line here, which goes through these 2 points, the points x and y of x and x plus h and y of x plus h. Okay, well, what we're going to do now, I guess, is kind of interesting. We're going to, let me just get rid of some of this extra detail. We're going to make h smaller. So let's make h a little bit smaller. I should use a new color. I never use this color very often. Okay, so let's make h a little bit smaller. Let's bring h in. So this is kind of the new x plus h, that point there. And so when we go up to our graph, we're going to hit about here, and on our y-axis, we would hit about here. Notice that, as notice that as h gets smaller and smaller and we get closer and closer to x, then so does, in this case, so does y of x plus h get closer and closer to y of x. And that's kind of important. That's called continuity, actually. Oh no, that's not called continuity, but that's a very important property we're going to need if we're going to be able to differentiate something anyway. All the functions we deal with in high school are pretty much going to be that way, so don't worry too much about that for now. If we meet any examples where that's not the case, we'll deal with them then. So let's just suppose that as h gets smaller and smaller, and x plus h gets closer and closer to x, then y of x plus h also gets closer and closer to y of x. Well, now look how that affects our line. If I draw the line through this point and this point now, it's going to look like this. And again, this may need a couple of attempts to get right. Oh, that one actually went pretty well. So the line is actually kind of bending around. The line's bending around. But also, if we kept doing this forever, we just kept making h smaller and smaller, our lines, are going to get, our lines are going to get closer and closer. Our lines are going to get closer and closer to a special line. Our lines are going to get closer and closer to a special line that looks like this. Our lines are going to get closer and closer to a special line that actually only touches our graph once around that point. So in other words, I can draw a small enough circle around this point such that inside the circle, the line only touches the graph once. Then that line is something that we call the tangent line. The tangent line. And you'll notice that as we keep making h smaller and smaller, well, this is the gradient of the line that goes through 2 points. As h gets smaller and smaller, as we may take h closer and closer to 0, this gradient is going to get closer and closer to gradients of the tangent line. So as h, I'll write that in a different color. As h gets closer and closer to 0, gradient gets closer and closer to gradient of tangent line. Remember, the tangent line is the special line that is such that only touches the curve once in a small neighborhood of the point. So like it touches the curve once in such a way that I can draw a circle around this point, and inside that circle it only touches the curve once. So maybe, maybe it keeps going and touches the curve here and, maybe somewhere else over here somewhere, I don't know. But the point is, if I take a small enough circle around that point, it's only going to touch the curve once inside that circle. So that line is special and it's called the tangent line. And if we want to work out its gradients, if we want to work out the gradient of the tangent line, we just keep letting h get smaller and smaller in this thing here. We let h get smaller and smaller in this thing here, this thing inside the circle, and as h gets smaller and smaller, this number, whatever number that is, will get closer and closer to the gradient of the tangent line. So let me write that out again. If I have a function, I'll draw it slightly differently this time. Maybe it looks like this. And let's suppose that our point x is here. So this is x. This is y of x. And this is my tangent line. This is my tangent line. Remember, it only touches the curve once in a small circle around the point. It only touches the curve once. That thing should be touching, by the way. Touches there. Okay, so my tangent line only touches the curve once, and I really should give the curve a name. The curve is y of x. Then, in that case, the gradient is equal to the limit as h tends towards 0 of y of x plus h minus y of x divided by x plus h minus x, so divided by h. So the gradient is equal to the limit as h gets closer and closer to 0 of y of x plus h minus y of x divided by h. In other words, we take this thing here for any values of h that are not 0, and we let them get closer and closer to 0, and we see what does the thing inside the circle get closer and closer towards. And whatever number that gets closer and closer towards, as h gets closer and closer to 0, that's our gradient of this tangent line right here. That's the gradient of our tangent line. So it's equal to the limit as h tends to 0 of y of x plus h minus y of x divided by h. Okay, so that is how to differentiate a function. When you have a function y of x and you want to find the derivative of the function at the point x, you want to find the derivative of the function at the point x, what you're actually finding is the gradient of the line that's tangent to the function at the point x and y of x. So you're finding the gradient of the line tangent to the function at the point x, y of x, and another name for this is actually y prime of x, and another name is dy over dx at the point x, dy over dx of x. So dy over dx is actually a function. Sometimes they leave the x out, but it really should be there. If it's not there, it kind of confused me anyway when I saw it was left out when I was back in school. Because I was like, what is this thing? Is it a function? Is it just a number? What? Well, it's actually a function of x, because when you put an x value in there, you're going to get a number out, and that number is going to be the gradient of the line that's tangent to the function at that point. Okay, let's do an example. So, our example is going to be as follows. Well, let's start out with a real easy one. Y of x equals x squared. Let's draw the graph real quick. So y of x equals x squared. Y of x, y of x, there we go. Sometimes it disappears for some reason. Y of x equals x squared. And let's do it at the point, let's say x equals 2. Okay, and this is my tangent line at the point where x equals 2. This is my tangent line when x is equal to 2. And of course, we know that y of 2 is equal to 4. And just looking at this gradient, just looking at this line, I reckon the gradient's about 4. I mean, I might be wrong, but I think just looking at that thing, the gradient is about 4. It's got, if this is like 1 unit, I reckon it goes up by 4 units. Let's see if I'm right. I'll give you a clue. And this time I'm actually right because I've seen the derivative before many times in my life. Okay, so let's differentiate it. We know that, well, actually for any x, I don't even need to put 2 in yet. We know that y prime of x is equal to the limit as h gets closer and closer to 0 of y of x plus h minus y of x divided by h. Carry on our working here. So that's equal to the limit as h tends to 0. What is y of x plus h? Well, y of x is equal to x squared. So that means y of x plus h is equal to x plus h squared minus y of x. Well, y of x is x squared. So minus x squared divided by h. Now I'll use a different color just to avoid confusion. That's equal to the limit as h gets closer and closer to 0. Now let's expand that bracket out. We know from year 10 algebra that when we expand that bracket out, we just get x squared plus 2xh plus h squared. So that's this bracket expanded. And then we're still subtracting x squared minus x squared, haven't touched that part yet, divided by h. Oh, that's great, because these x squareds just cancel. I got plus x squared minus x squared. And so, what are we left with? Well, we can also, we're taking the limit as h goes to 0. So, in other words, we're saying as h gets closer and closer to 0, what number does this thing get closer and closer towards? And so that means that h is never actually equal to 0. We don't care about what happens when h is equal to 0. In fact, in this case, when h is equal to 0, it's not even defined, because then we'd be dividing by 0. So we don't care what happens when h is equal to 0. All we care about is what happens as h gets closer and closer to 0. Well, for all non-zero h, we can actually cancel these h's off. So we can cancel these guys, and then we cancel one of the powers. So 2xh divided by h is 2x, and h squared divided by h is just h. And of course 2xh plus h squared divided by h is the same as 2xh divided by h plus h squared divided by h. So we can just cancel those off and it's fine. And what we're left with is the limit as h tends to 0 of 2x plus h. Well, I don't think it's hard to see that as h gets closer and closer to 0, 2x plus h just gets closer and closer to 2x. So our derivative of y of x equals x squared, turns out y prime of x is actually equal to 2x. So whatever x value I choose, the gradient of the line that's tangent to the function is going to be equal to 2 times that x value at that point x. So in this case, what we started out trying to work out, before I got a little off topic, what we started out trying to work out is what's the gradient of the line when x is equal to 2? And I said, well, gee, I guess it's equal to 4. Hey, it turns out I was right, because we can see that when we let x equal to 2, then our gradient, y prime of 2, is equal to 2x, so x is equal to 2 here, so that's 2 times 2, and that's equal to 4. So the gradient of this line is indeed 4, as I thought it was. What a coincidence, I got that one right. Okay, so that's the basics of differentiation. I'll do that next time. I'll do another video with one more example. Okay, thanks very much for watching. Hope you learned something. See you guys next time. Take care. Bye.